Okay, so it's asking sucrose has a chemical formula of this, and these are the reactions. It's going to ask you to do some other things later on with these things. We've got these missing numbers here, which we're going to probably do possibly a simultaneous equation or something like this. Then we've got okay, so let's go through these stages. Identify the known and target substance. I've coloured in the known substance in red everywhere and the target substance in green nearly everywhere. And okay, so it says find the molar mass of each one. Well, they've given us that already. It's here and here. Number 3, convert the mass of the known substance into moles. Forget about that example. That was from a previous example. Obviously, ethanol and oxygen. So we're going to find the molar mass, which is that, and we've got the 6.86 grams. So we're going to work out how many moles is 6.86 grams of sucrose. We would just times it. Hang on a second. No, we would divide it by 343, and we find out it is 0.02 moles. So we have 0.02 moles of sucrose. Now, stage 4 says use the equation to find out the ratio. So this equation tells us that if I had 1 mole of that, then presuming I've got enough of everything else, I could get 12 moles of this. So the ratio of the target to the known is 1 to 12. Whatever amount of the target, I'm going to get 12 in terms of moles. In terms of moles, I would get 12 times as much of the target. I already know that I've got 0.02 moles of the target substance. So of the known substance. So I'm going to get 12 times that of the target substance, which is 0.24. So that's the answer. So looking at the second part, a student heats 5.83 grams of sucrose. This is going to be the known substance, isn't it? In a sealed container to ensure incomplete combustion. 3.80 grams of carbon monoxide, that is, and 2.99 grams of carbon dioxide are produced. Rewrite equation 2 as a balanced equation. Let's have a look at equation 2. Yeah, as you can see, we have some unknown values here. So what we have to do now is use the basically it's my cheat sheet doesn't entirely work this time because they've done it backwards in a way. They've rearranged the problem. So they've given you all the masses and asking you to, from the mass, work out what the ratio of one thing to another would be, and therefore in terms of moles, and then you would use that information to work out what the balanced equation is. Okay. So this time we might want to use a different kind of color colors code. Struggling with my words. So we've got the grams of the sucrose. That's this over here, and we've got the grams of the carbon monoxide, which is this one over here. And then we've got, let's use an orange. We've got the grams of the carbon dioxide, which is this one here. It looks like they've not told us the the moles of oxygen, and they've not told, and yeah, these two are blind, but we do know this one. So yeah, so the stages to work out this problem would be to use this mass. Well, basically you've got 3 masses, and you've got the formula for each one. In fact, in the earlier part of the question, it gives you the molar mass anyway, or the relative formula mass, whatever you want to call it. It is the molar mass. So you can work out, using that information, how many moles we've got. We've got the masses, we can work out how many moles we've got. From that, we can work out the ratio, and from that, we can plug that in and put that into the formula. So the first stage in this new type of problem would be to convert the masses to moles. What they've done with all these questions is that they've made it difficult to visualize by using awkward numbers. So there's a cheat around this. I mean, first of all, obviously you can just remember the formulas, but I think there's nothing wrong with that. Obviously, it's quite a good idea, but sometimes you might forget, and so there is always a way around it. Well, usually there is a way around this. So what we're trying to do is say, how do you turn mass into moles again? We've got the molar mass, we've got the mass. How do you turn that into molar mass? We can work out the formula because let's imagine that the molar mass, so basically give ourselves some easy numbers. Let's imagine the molar mass was 20 grams and the mass was 40 grams. We know that the answer is clear. The amount of moles is clearly going to be 2. And we got that by doing the 40 divided by 20. So therefore, number of moles is going to be equal to the mass divided by the molar mass. So there's always a way to remind yourselves of the formula by giving yourself a different problem that is easier to solve. So moles is equal to is going to be, what did I just say? Mass divided by molar mass. Okay. Let me get rid of that example. That was the molar mass. The molar mass is how much one the molar mass is how much 1 mole would weigh. These are all the masses. We've been given this amount, these hypothetical amounts, and then we consult the data from above to see how many moles that would be. So in this case, for the sucrose, 5.83 divided by whatever sucrose was. Sucrose was, here it is, 343. So we do 583 divided by 343. That would give us our sucrose. So we have divided the mass by the molar mass and got the 2.4. Does that say 2.4 or 2.9? I meant to say 0.24. 0.24 moles. And we got carbon monoxide, mass divided by molar mass, 3.8 divided by 28, 0.136 moles, and the same 2.99 divided by 44 for carbon dioxide, mass divided by molar mass, 0.09 moles. So we've got all the different amount of moles now, and we're going to use that to work out the ratio of one to the other. Okay, so we're going to say that. So in other words, can we work out, and there will be probably some rounding up. Can we work out what ratios these would form? The sucrose to the carbon monoxide to the carbon dioxide. What ratio would that be? That's what we need to do now. So we're not using the ratio from the balance equation. They're working out the ratio. Okay, so for the video, we just noticed that we somehow must have typed something wrong in the calculator. So that's 0.017 moles, which makes sense because now we've got to try to see how many times does 0.017 fit into that and fit into that. Essentially, that's what we're trying to do. Now, you got to look for common multiples. You got to look for something where it's near a common multiple. 9 is going to be a multiple of 18, which is near to 0.17, 0.01, well, near to 17 basically. So that's going to give us an idea to work out the ratio of that. And then we've got to, now the next stage would be to work out 0.136. How is that? What's the nearest multiple? What way would we have to round up or round down to get this to fit into that? So what we're doing is we're trying to use these numbers to work out what ratio they correspond to. Let me just move this cheat sheet for the previous question out of the way. It didn't actually work because we had to do a different thing, but yeah, it did. Oh, never mind. Right, so we're trying to work out the ratio. So we know that this one has to be going to be 1 because it's 1 in the balanced equation. So we want to see how many times does 0.017 fit into 0.136. To do that, we just go 0.136 divided by 0.017. And when you do that, you get the answer 8. So far, it's going to be 1 to 8. And then we do the same here. We say how many times does 0.17 fit into 0.09? So now we go 0.09 divided by 0.017. Now it's going to give us a number close to, it gives us the number 5.3. So if I change that, number to 0. So if I change it to 0.09 divided by 0.018, I get a nice 5. Okay, so it's 0.017, it's very close to 0.018, right? So we would say it's roughly 1 to 8 to 5. That would be our ratio, 1 to 8 to 5, in terms of those formulae, which means that we would go, there's our 1. Okay, let's just color these in. So there's our... So that one is a 1, which is already in the equation. As I said, I knew that it was going to be a 1 because they could have made it harder. They could have left that blank, and it could still be possible to do it. But they didn't leave it blank. They left it. They told us it was a 1, which meant that we know that that would be 1 there, and we know that would be 1 to something, and that would be 1 to something there. So the next one is we look at. So then we go to the carbon monoxide, which is going to be 8, and then we go to the carbon dioxide, which is going to be 5. So now we've got the values of each one. We can then use these values to work out what amount of moles would have to be here in order to make the equation finish balancing it. Well, it's basically already half balanced, isn't it? So we would just have to count up the oxygens on the right that we've counted for so far, and the oxygens that we've counted for so far on the left, and see how many more we still need to add, and we'd use that number to work out this. Okay, so we've got 11 oxygens on the left. On the right, we've got 8 plus 10 from the 5 loss of CO2, and then the 11 H2O, so that gives you 11. So it's 8 plus 10 plus 11. Take away the original 11 from the left. So we've got 8 plus 10, so that's going to be 18, and O2, so we would need 9 moles of O2. So altogether, we've got 1 mole of sucrose would react with 9 moles of oxygen to produce 8 moles of carbon monoxide and 5 moles of carbon dioxide and 11 moles of water.